The first example of equation solving in 2.7 day 1 is this one right here, probably the least complicated of the ones that we're going to be working with today. We have x plus 2 is equal to 15 over x. This is part of our chapter because it involves 15 over x. It has something involving a fraction. Now, we don't have to factor anything here, so the first step isn't really an issue, but we do need to do the second step, which is multiply everything by the least common denominator. Now, in this case, it's pretty easy to figure out what that is because there is only one denominator. There's an x, and so we're going to use that as our LCD in this case. We're going to multiply everything by it, so we're going to take the entire equation, both sides, multiply by x. The whole reason for this is to get rid of the x down here to make sure that we have no fractions involved in the problem. So when we multiply over here, it's just going to be 15 then on the right-hand side. When we multiply on the left-hand side, we're going to have x squared plus 2x, and that will be our equation. So now it looks like we're dealing with a quadratic equation, which we are. And so to solve that best, we want to get everything on one side. So I'm going to subtract the 15 over to the other side. We have x squared plus 2x minus 15 equals 0. This is a traditional quadratic problem. We can do this by graphing. We can factor it. We could use the quadratic formula if need be, but I like to do the easiest method possible, and I think that's going to be factoring here. If factoring doesn't work, then you maybe default to some other ones. This expression factors into x plus 5, x minus 3, because 5 times negative 3 is negative 15. 5 minus 3 is 2, so that one works. If you're having trouble with factoring, you might want to pause and just try to factor it on your own first, see if that makes sense to you. Once we have that, though, we have it in a form where we can solve now. X equals negative 5 or 3. Now, these are our two solutions, and they actually do both work, but I do want to mention that later on when we're working on these examples, you want to plug these into the original equation and just see that that original equation turns out to be true. If it's not true, then we would cross it out and be an extraneous solution, but in this case, these both happen to work.